2C, evaluate the integral 0 to 3.5 of v of t dt, and evaluate the same integral, but from 0 to 3.5 of the absolute value of v of t dt. Interpret the meaning of each integral in the context of the problem. So we'll interpret the meaning first, in that the integral under v of t dt represents the displacement of the function, the displacement of the position. So it represents where the difference between where it started and where it ended at 0 and 3.5. Whereas the absolute value of v of t represents the total distance traveled. So going forward and backward does not count against each other, but going backward counts as distance as well. So when we look at evaluate those integrals, again, this is a graphing calculator section. So we want to use our graphing tool. So we've already graphed that function. And so we're just going to integrate. So we're going to use the integrate function, and we're going to do that from 0 to 3.5. And the value that we get is going to be 2.8439. And that value represents the total displacement in meters from time 0 to 3.5. And we can see that area is shaded. And when we shade that area underneath the curve, okay, so this area in here, this would count against the positive area above the curve. The value of the absolute value, so what we can do is then, for this one, we can just put the absolute value around the function and integrate this. We could also work out the intersection point of this point here and then calculate the area under the curve up to that point, and then do an integral and find the area underneath or below the line from that point to 3.5, and then count that as the opposite. Or we can just graph it as an absolute value, and when we graph this as an absolute value, we end up with that negative part above, and we can see that portion here that was counting against the positive area is going to count with the positive area. And that distance traveled is going to be 3.7370, or rounded 71, and that represents the total distance that was traveled. We can see that the difference in those two graphs kind of indicate the difference in the concepts as well. For D, it says a second particle moving along the x-axis was position given by t squared minus t from 0 to 3.5. At what time t are the two particles moving with the same velocity? Well, velocity means that if we look at the derivative, x2 prime of t, that's going to give us the velocity of the other function, and we want to know where the velocities are equivalent. So first thing is I'm going to differentiate that function to get the velocity function. So differentiating that, I get 2t minus 1. And then we want to find the t where the two particles are moving with the same velocity. This is when the x prime of 2, that function, is equal to the original velocity function. And I forget how we notated it, it was just notated as v of t. So where those two are equal, we're going to find where the velocities are the same. So what we want to do then is, we've already graphed the v of t, that's in blue here, and then we're graphing the x prime of 2, and we end up with 2t minus 1, and we can see that green line represents 2t minus 1. If we want to know where they're the same, we're going to just graph them on the calculator and intersect those two functions. We do not want to solve this algebraically because it would be much too complex. So if we just intersect them using the intersect function, we're going to get a value of, looks like 1 point. That value is 1.5705, and that represents the time at which the velocities are the same. So t is equal to 1.5705. For the mark scheme, if we take a look at the mark scheme for C, there's 3 marks. Okay, the answers for the 2 areas are going to give 1 mark, and the interpretations of the absolute value of v of t and the integral of absolute value of v of t and the integral of v of t are going to give us the other 2 marks. For part D, it's worth 2 marks. Okay, we just for 1 for the answer and 1 for making these 2 values equal to each other. So making this equal to one another gives us one of the marks as well.